One of the challenges that students sometimes have in linear motion is solving problems. So in this video, I'm going to be showing you how to use the equations of linear motion to solving problems involving linear motion. So let's get started. Now we have three equations of linear motion. The first one says V equals to U plus AT. The second one is V squared equals to U squared plus 2AS. And the third is S equals to UT plus half AT squared. Now the V represents final velocity, the U represents initial velocity, the A represents acceleration, and the T represents time, while the S represents distance. Each of these equations of linear motion can be used to solve different problems of linear motion depending on the way the problem is presented to you. So in this question, I'm going to be walking you through how we can use any of these three equations of linear motion to solve the problem we have on the board. All right. Now it says a boy on a bicycle accelerated uniformly at 1 meter per second square for 10 seconds from an initial velocity of 4 meters per second. Calculate the distance traveled in this time. So let's see how we solve this problem by applying the equations of linear motion. So I'm going to write solution. Okay, now let's go back to the equation. It says a boy on a bicycle accelerated uniformly. So the first value we are given there, we extract it out. A is 1 meter per second square for 10 seconds. That is the time. We write that one out to T is equal to 10 seconds. 10 seconds. Then it says from an initial velocity of 4 meters per second. So that is U. U is 4 meters per second. Now we are asked to calculate the distance traveled in this time. So we are looking for S. Now I always advise my students to start by itemizing the values, by extracting the values from the question. It makes it easy for you to know which formula you are going to apply based on the given values. So what I'm now going to do is to look at each of these three equations of linear motion. Based on the values I've been given, which of them will be most appropriate for me to use in solving for the distance traveled in this question. Now I have my A, my T, my U, and my S. Which of them contains all these given values and allows me to use the S to solve for distance. Looking at it now, equation 1 doesn't have an S. Equation 2 has an S, but I don't have a V in what I'm giving. Now, equation 3 has an S. It doesn't present me with a V because I don't have a V here, but I have a U, which is this, and I have a T, which is this. And of course, I have my A, which is this. So obviously, equation 3 is the most appropriate for me to use in solving this problem. So I'll go ahead and use equation 3. So I will now say using S equals to UT plus half AT squared. I will insert the values as have been given there. So let's look at that. S equals to U. What is my U? My 4 times T. My T is 10. So close the bracket there. Then you add the plus half times A. A is 1. Then times T. T is 10. So 10 squared. So that becomes 4 times 10 is 40. Then plus half times 1, that's 1. then times 10 squared, that is 100. So that becomes 40 plus half of 100 is 50. And when I add that together, I have my 90 meters. So the distance traveled by this boy on his bicycle is 90 meters. Now, one question that students may likely want to ask is that, are we now saying that it's only equation 3 that can be used to solve this problem? No. You can actually use a combination of equation 1 and 2 to also get this 90. I'm going to show you how that is done. So if I'm going to use equation, because equation 2 has my s, and I'm told to look for s. If I'm going to use equation 2, I will need to first of all find my v. So in finding v, I will use the first equation. So let's see. Alternatively, using v equals to u plus at, I will find my v first of all. V, which is final velocity, is u, that is 4, plus a is 1, then multiply by t, which is 10. So that becomes 4 plus 10, which gives me 14 meters per second. So this is the final velocity of the boy. I need this final velocity, which I'm going to insert into equation 2, and then make my s the subject of the formula. And by that, I'll be able to get the distance. So let's look at that. So I now say, substitute for v in equation 2. Substitute for the final velocity, which is 14, in equation 2. So let's look at that. So from v squared equals to u squared plus 2as, I have that my s, because it is the s I'm looking for, the distance traveled, I'm going to make that my s the subject of the formula before putting all the values of my v and my a and my what else, my u there. So s equals to v squared minus u squared all over 2a. So let's look at that. What is v? My v is 14, that's squared, then minus my u is 4, that's squared, all over 2a, that is 2, times 1. Now, what is 14 squared? 14 squared is 196, minus 4 squared is 16, then all over 2. Now, what is 196 minus 16? That is 180, all over 2. When you divide your 180 by 2, what do you get? You get 90. So the same 90 meters that we got when we were using the third equation of motion is also the same 90 that we have gotten when we use a combination of the first and the second equation of motion. So you can actually use any of these three based on how well you understand each of them and how to apply them. But I always tell students that when you are given a problem, look at the one that quickly helps you to solve that problem. Look at the equation that carries all the values you are given, and then go ahead and quickly solve for the unknown. But this other one that we just did is just for you to see that you can also use any of the two that we didn't use initially to also get the same answer. So I believe with this you have understood how to use and apply equations of linear motion. Thank you.